Hello everyone, this is Steve from Unwired Tools, and today we're going to deal with a beautiful Mercedes 1983 380 SL who's got an idle speed which is completely out of control because its idle air valve controller is broken. Common failure on these cars. For most cars, certainly all made after 1980 was Bosch CIS fuel injection. There is an idle air valve. You can see that here because it's this round gadget with this little 2-pin connector. And you can tell that somebody has been in here before because someone has tried a repair with these awful crimp-on connectors, which you can see has actually gotten some heat distorted and they're covered up. So we earlier got in there to diagnose the controller and it's shot. It's got an internal failure. So we're going to deal with that today the easy way. So rather than getting into the engine compartment back in there and digging that thing out and trying to repair it or replace it, we've got an easier solution, and that is the Unwired Tools idle air controller. This tiny little gadget, which is only about 1.5 inches square, that does the job, and it's very easy to put on. So what we're going to do is we're going to start by getting power for it, which is the connector for the warm-up regulator. Now, I've already loosened this, just so I can show you what to do here. The thing to remember about these connectors is that these have these little wire bails, and what you have to do, and by the way, we include a small screwdriver with the idle air controller to do an adjustment if you need it. So what you need to do is find the ends of that little wire bail and push those to the side, and that will release the little strain reliefs on the side. You can see this one's already been broken here. This one's still okay. But on the new one, on the replacement, this is actually quite a bit easier to deal with. So what we need to do is plug in this power input connector, and that will just nicely snap in place. So this supplies power to the idle air controller, and then this one just passes power through to the warm-up regulator. And you can see this release tab on our new connector is quite a bit easier to work with. And then this just goes right onto the power connector of the warm-up regulator. Right there, just like that. Okay, so that's power. Then to connect the idle air valve connector, that is this guy right here. This is the correct connector for this. And this connector is not polarized. It can go on either way. And that just goes on there, on these two pins, just like that, and that's snapped into place. So now this can be, the little controller should be accessible in case you need to make an idle speed adjustment, because one of the neat things about this little controller is that it restores manual control of the idle. So you can tie wrap it off here or put it underneath here, anywhere you like. And that's it. That is now a replaced idle air valve controller. So now let's see if we have idle speed restored. The new idle air controller has been installed. It was a chilly morning, about 39 degrees Fahrenheit overnight. And so let's see how we do on a cold start with proper idle air. Okay, didn't even have to touch the throttle. Started off a bit low, only because it was pretty cold. Cold start at this temperature, the whole cycle should take about 3 minutes. So as the warm-up regulator is ramping up control pressure, the idle air controller should be slowly throttling down the idle air. The idle air valve actually started out as fully open, but it wasn't over 1,000 RPM only because it was stone cold. As you can see now, the RPM is settling back down to its final value because it's warmed up enough. See, the needle's already moved off of 0, and it's settling into a beautiful smooth idle. And that's how a nice cold start is supposed to work. And that's it. That's the final value.